Hi oceanography students. We're doing a little module here on the formation of tides. Most folks in California are familiar with the daily rise and fall of the tides. In some places it's really quite dramatic. These two pictures are from the Bay of Fundy, in Canada, and where you can see that the tide goes up and down by many feet. In fact, there are places in the Bay of Fundy where the tidal range, the vertical change from high tide to low tide, is as much as 50 feet. Now here in San Diego, the tidal range is at most about 9 feet, so it's not quite as much. But that's one of the numbers that you'll be thinking about as you do your lab today, this number called the tidal range, the vertical change between high tide and low tide in feet, and what kind of factors control the tidal range. We're going to be trying to answer that question in the lab. Now, you're already familiar a little bit with the tides because you've been on a field trip to the intertidal zone where you saw a lot of interesting creatures that live in that area where that's exposed to the air at low tide but covered up at high tide. And so the intertidal range zone is an interesting place, and tides are also important because we can generate electrical power with tides, and more places around the world are doing this, capturing the movements of currents created as the tide rises and falls in bays and estuaries. So there's a lot of reasons to understand and study the tides, and one of the things you're going to be doing in the lab is making what's called a tidal curve. This is a tidal curve for an entire month, and it's basically a graph that shows the changing height of the ocean over time. And the peaks on the graph represent high tides, for example, a high tide here and a high tide here, and the valleys on the graph represent low tides. Let's go zoom in on one part of the graph just down here, just so we can look at it in a little more detail. So for example, on the 27th, you can see there's a low tide, a high tide, another low tide, and another high tide. Now, these numbers down here tell you the time and the height of the tide. So this low tide occurred at 3:27 a.m. and it was 2.1 feet high. What that means is that it was 2.1 feet above zero, and the zero tide is defined as the average of all the low tides. Okay, that's by international agreement, that represents zero sea level. And then this high tide occurred at 9:43 a.m. and it's 7 feet above zero. And then there's a low tide at 4:58 p.m. and it's minus 1.2 feet. This is what we call a minus tide or a negative tide, a tide that's actually lower than the average of the low tides. And then we have another high tide at 11:33 p.m. just before midnight, and it's 4.2 feet high. Now notice on the next day the pattern looks similar, but the timing is later. You see how this high tide was at 9:43 in the morning, this high tide's at 10:30 in the morning. And the other tides advance as well. On average, the tides move ahead every day by about 50 minutes, and one of the reasons I'll explain in just a minute. Well, people have known for a long time that the tides follow the moon, that there's a connection between what the moon is doing and what the tide is doing. And one thing that we now realize is that the moon actually distorts the ocean into two bulges of water. There's always a bulge of water that faces the moon and a bulge of water on the other side of the Earth away from the moon. And we call these tidal bulges, and they're not nearly as big as shown on this picture. That's just an exaggeration so we can see it. And really the reason we have tides is that the Earth spins underneath these bulges. And when we spin through a high place in the bulge, we feel it as a high tide, and when we spin through a low place, we feel it as a low tide. And essentially the Earth spins through two high bulges and two low places every day, which is why we have two high tides and two low tides. But remember back to the graph where we saw how the tide advanced every day? Well, we can understand that by thinking a bit about the movement of the moon as the Earth spins. In this diagram, we're starting out and we're going to call it 0 hours, right? And the Earth is rotating this way. And in this diagram, 8 hours later, the Earth has spun 1/3 of its rotation and the moon has advanced a little bit. And then 16 hours later, the Earth has spun 2/3 of the rotation and the moon has advanced further. And after 24 hours, you're back where you started, but notice that the moon has moved ahead a little bit. Now those bulges of water, you can see that they always are oriented with respect to the moon, right? And what has to happen here is the Earth has to spin an extra 50 minutes for you to get underneath the moon again. And that's why the tides advance by about 50 minutes a day. An analogy here would be a minute hand and an hour hand on the clock. You know, the minute hand spins faster, it's like the Earth here. And it has to go a little farther every time to catch up to the hour hand, because the hour hand is going in the same direction, only slower. What you're going to do now is want to go look at the second video to continue with these concepts. I've given you enough information here for you to answer some of the questions on the pre-lab exercise.